Welcome to How to Succeed in ECE Without Really Trying. I'm Dr. Linda DeBrunner, and in this video, I'm going to go through an op-amp analysis example that has pretty messy algebra. Here's another circuit. So anytime we're analyzing an op-amp circuit, we do the same three things. We know that the inputs to the two terminals of the op-amp, or the input currents, are both zero. We also know that for negative feedback, which we have, V minus is equal to V plus. The third thing to do, remember, is that you want to write nodal equations at the nodes here, at the input terminals. So at the plus terminal, we know that V plus is equal to V in. That one was easy. And at the minus terminal, we're going to write a nodal equation, okay? And we end up with V minus minus 0 over 1 over SC plus V minus minus V out over the series combination of RF and 1 over SCF. And that will be equal to 0. So again, remember we're going to add this current, which is V minus minus 0 over 1 over SC, to this current, which is V minus minus V out over RF plus 1 over SCF, plus this current here, which is 0. So I didn't write it. And we end up with this equation. So at this point, we just need to do a little bit of algebra. We can plug in for V minus will be equal to V in. So when we plug that in, we end up with this equation. Still quite a bit of messy algebra left to do. So the first thing we're going to do is group the V ins on one side of the equation and V out on the other side. So we collect all the V in terms, that's here. The V out term is here. Then we find the ratio of V out to V in. It's a giant mess right here. First thing we're going to do is multiply through by RF plus 1 over SCF over RF plus 1 over SCF. So this term right here is 1, of course. And that's going to clear up a few things. That's going to make this denominator here be 1. That's going to make this term here be 1. And then we'll have a RF plus 1 over SCF. Be sure when you're doing this kind of computation that you don't forget this little SC over here. Don't forget to multiply it by the term as well. So that'll give us 1 plus SC times quantity RF plus 1 over SCF. Okay, so we'll multiply that by SCF over SCF, and that'll give us SCF times 1, FCF times SC, which will give me times RF, which will give me S squared CFC RF, and then SCF times SC times 1 over SCF, which will give me SCS. I'm sorry, FC, there's a typo, sorry about that. SC. Okay, so then when we simplify that a little bit up, we'll end up with S squared CFC RF, that's this term, plus SCF plus SC, and then divided by SCF. So that is our actual transfer function. It'll be V out over V in. And that's the transfer function then. H of S is equal to V out of S over V in of S. And we end up with S squared CFC RF plus S times quantity CF plus C over SCF.